All right, today we're going to dive into something that's, absolutely essential in the world of Linux, file permissions. Now, this isn't just some boring technical detail. Nope, this is the heart of Linux security. It's what decides who can see, who can change, and who can run literally every single thing on your system. Getting this down is, well, it's key to mastering Linux. So, let me just ask you a question. When you're on a Linux system, who's really in charge of your files? Who gets the final say on that important script you wrote, or that super confidential document? The answer is simple, and honestly, it's pretty empowering. In Linux, you do. The whole system is built to give you incredibly precise control, and today, we're going to show you exactly how to use that power with file permissions.
Okay, let's start with your first line of defense. Every single file, every single directory is wrapped in this three-tiered security model. If you can understand these three levels, you're well on your way to locking down any Linux system.
So let's break this down. First, you have the owner. This is usually you, the person who made the file. You get the most say. Next up is the group. This is awesome for teamwork, right? You can give a specific set of users shared access. And then there's others. This is pretty much everyone else on the system. This simple structure is the foundation of it all.
Now, I'm sure you've done this. You've typed ls-l in a terminal, and you see this string of letters, something like -r, wx, rx, r-. It looks like gibberish at first, right? Well, we're about to crack the code. That little string tells you everything. Look at this. It makes it so clear. That 10-character string is really 4 parts. The very first character, that just tells you the file type, a little dash for a file, or D for a directory. But the next 9 characters, that's the good stuff. It's split into 3 tidy little blocks, one for the owner, one for the group, and one for others.
So what are R, W, and X really mean? Here's where it gets interesting, because their meaning actually changes a bit depending on if we're talking about a file or a directory. For a file, it's totally what you'd expect. Read to see what's inside, write to change it, and execute to run it. But for a directory, execute is the magic key. It's what lets you cd into it. Without that X, the door is locked, even if you can see what's inside.
All right, knowing what permissions are is one thing, but actually changing them? That's when you really take the driver's seat. And for that, our go-to tool is the chmod command. It literally stands for change mode.
So, with chom mode, you've got 2 ways to do things, symbolic and octal mode. Symbolic mode is super intuitive. You just use letters, like U for user, G for group, a plus sign to add a permission, a minus to take one away. It's perfect for a quick little tweak. Then you have octal mode, which uses numbers to set everything all at once. It is wicked fast once you get the hang of it.
And this is the secret code. It's just simple math, really. Read is worth 4, write is 2, and execute is 1. You just add them up. So if you want read and write, what's that? 4 plus 2 is 6. Want all of them? Read, write, and execute? 4 plus 2 plus 1, that's a 7. So when you see a command like chmod 755, it just means the owner gets full control, that's the 7, and the group and everyone else can read and execute, that's the 2 5s. Simple, right? And so powerful. Okay, so permissions are only part of the story. The other, equally important part is ownership. You have to be able to say who the owner and the group for a file even are. So let's see how we do that.
For this, we have 2 main commands, chown, which is short for change owner, and char group for change group. But hey, here's a little pro tip for you. Chown can actually do both at the same time. If you use the format chown user/group, you can set the owner and the group in one clean shot. Super efficient.
All right, we've covered the fundamentals. Now it's time to get into the really cool stuff, special permissions. Think of these as power tools for very specific and very important security situations. So there are 3 special permissions you absolutely have to know about. There's SUID, or Set User ID, which is all about user privileges. Then we have SGID, or Set Group ID, for group stuff. And finally, the wonderfully named Sticky Bit, which helps manage shared folders. Each one does a very specific and very powerful job.
First up, SUID. Here's the deal. When you set this on a program, anyone who runs that program temporarily borrows the power of the file's owner. So it lets a regular user perform a specific action with, say, root privileges, but only for that one task, and in a very controlled way. It's a huge deal for certain system commands.
Now, SGID is kind of a chameleon. On a file, it's a lot like SUID, but it works on group permissions instead.
But where it really shines is on a directory. When you set it on a directory, any new file created inside automatically gets the directories group. It makes collaboration a breeze, because you don't have to worry about permissions for every new file.
And then we have the sticky bit. This one is all about playing nice in shared spaces. When you put this on a directory, it lays down one critical rule. Even if everyone can create files, you can only delete or rename the files that you own. It's what stops people from deleting each other's stuff in a shared folder. Total chaos prevention.
Okay, theory is great, but let's connect this to reality. Let's look at where you actually see this stuff working every day on a Linux system, and just as important, some really dangerous mistakes you have to avoid.
The funny thing is, you've been using these special permissions all along and probably didn't even know it. That password command you use to change your password, it uses sudo. It has to, so it can write to a file that only the root user is supposed to touch. The /tmp directory uses the sticky bit, so we all have a safe place for temporary files. And those shared project folders, SGID is the hero that keeps all the files owned by the right team.
Okay, now for the big warnings. First rule, just don't use chmob 777. Seriously, it gives everyone full control, and it's like leaving your front door wide open with a sign that says, "Come on in." Second, be so careful with SUID. Putting it on the wrong program can literally create a backdoor for an attacker to get root access. And a classic mistake, don't forget you need that execute permission on a directory just to get inside it.
So let's do a quick recap. The essentials are your permissions: read, write, and execute for the owner, group, and others. The command to change them is chmod. The commands to change ownership are chown and chgrp. And when you need more firepower, you've got your special tools: SUID, SGID, and the sticky bit. So we've gone through all the tools, all the concepts. You now get how Linux guards every single file, and how you can be the one in charge of that whole system. The only question left to ask is, now that you have the keys to the kingdom, which doors are you going to go lock?